Hello again, Tom from EveryStepCalculus.com, EveryStepPhysics.com. Lagrange multiplier, this is the third one I've did here today, because this involves when you get to the equations that you're going to solve for x, y, and z. So it's a different system. Remember the last one I did was you sum up, multiply both sides by x, y, or z, and to make one side equal. And sum both sides. Well, this one is to solve for x, y, or z, okay? So let's do it. Index 8. These are all setup problems. These are pathetic in calculus. In calculus 3, we have to figure out how to do this. It takes a long time to study it, so you might just as well use my programs and let me do the studying, which I've done for a month here to get the x, y, z, 3 variables going. So anyways, index 8 to get to my menu. And I'm going to scroll down here to Lagrange. There it is there, Lagrange. And we're going to choose x, y, and z, number 2. I am going to do several more on 2 variables, x, y. And I've already entered these functions into the simulator here, but you're gonna, I say it's okay, you're gonna enter them yourself, and why you do that by pressing alpha first and then putting in alpha x squared plus y squared plus z squared, and then equals 25. My programs require that the 25 remain on the right of the equal sign here. Some problems will give you minus 25 equals 0. But I need to pick out this 25 within the program to do something with it. So I need it on the right side. But my programs will automatically tell you if you do that, and you'll be able to correct it. Okay? I try to cover all the basis on these, and of course the partials for the f, x, y, z is 3, 5, and 2. You can see 3, 5, and 2. That's the partial derivatives of that. And with regard to g of x, we're adding the lambda here, Lagrange multiplier, which is adding lambda to the g of x, g of y, g of z. Of course, x is 2x lambda, 2y lambda, 2z lambda. And the system of equations, change of f equals the lambda change of g, 3, 5, 2, etc. right here. Make sure you write all this down in your paper so that you look like a genius. Now we're going to solve for x, y, and z. So x is equal to 3 divided by 2 lambda, y is equal to 5 divided by 2 lambda, and z is equal to 1 over lambda. We sub into the constraint, which is x squared, y squared, z squared equals 25. And we do the calculations, and this is what we calculate. We're going to solve for lambda, and the answer is square root of 38 over 10. We're going to replace the value of lambda into x equals 3 divided by 2 lambda, which is equation 1, or the solution for x with equation 1. And so x equals, we're putting this in for lambda. Notice I use quotation marks, or the calculator does. I can't use, but you'd use parentheses, okay? 2 times parentheses square root of 38 over 10, okay, on your paper. And the answer is x equals 15 times square root of 38 over 38. And we do that for each one into the y answer we got for the second equation. And for the third equation, Here's the answer for z. We place this into the f of x, which we're doing here. F of it is equal to 5 times square root of 3819. It's 3x plus 5y plus 2z. The maximum is equal to 5 times square root of 38. Okay, that's the answer. Okay. Go to my site, buy my programs, and pass calculus. I do the study, you do the passing. Okay. Hey, have a good one. Good luck in your classes.